Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that consider the velocity time graph below. So these are the graphs. Yeah, graph A, this one, B, and C. And then the question says that comment on the velocity of the object represented by each of the graph above. Okay, let's start with A. Yeah, what can we say about velocity of the object represented by this graph? Yeah, this is the velocity, and what do we see? It's going up, so it is uniformly increasing. Yeah, then we come to B. Yes, what can we say about velocity of object B? Yeah, it is uniform. Yeah, then we come to C. Yes, what can we say about velocity of the object with this graph? So what do we see? This is the velocity, and we see it's decreasing. But it is uniformly decreasing because it's a straight line. So what are you going to say? It is uniformly decreasing. Yeah, then we come to this one. It says that comment on the acceleration of the object represented by each of the graph above. Okay, what is the acceleration of A? Yeah, for A, it's a straight line, so it is uniform and positive. Yeah, uniform because it is a straight line, and positive because the slope is positive. Then we come to B. Yeah, what is the acceleration of B? B is moving with uniform velocity. And what does uniform velocity imply? It implies that acceleration is zero because there is no change in velocity. So for B, acceleration is zero. Yeah, then we come to C. Yes. What can we say about acceleration of C? Yeah, acceleration of C, it is uniform but negative. And negative acceleration is called deceleration. Yeah, then we come to this question. It says that consider the graph below showing the motion of the cyclist. So this is the graph. It's a velocity, a time graph. And the question says, state what each of the following represent. And the first one says, slope of the graph. Yeah, what does the slope of the graph represent? For a velocity time graph, the slope represents acceleration. Yeah, then we come to the next question. This one. It says that what does the area under the graph represent? Yeah, what does the area represent? It represents displacement. Yeah, then we come to this question. It says that briefly describe the motion of the cyclist in each of the sections below. Yeah, the first one is W. Yeah, what kind of motion is this one? That one is uniform velocity, uniform or constant velocity. Here you can see it at 0 it is 10, at 25 it's 10, at 100 it's 10, so it's constant. Yeah, now we come to section X. Yeah, what kind of motion is that? How do we describe it? That one is uniform acceleration or constant acceleration. Yeah, then we come to this one, Y. Yeah, what do we see? It is uniform or constant velocity. Yeah, and then we come to section Z. Yeah, what is happening at section Z? It is uniform negative acceleration, which we call deceleration. Yeah, then we come to this question. It says that calculate the acceleration of the cyclist in each of the sections below. Yeah, the first one, W. Okay, what is acceleration? Acceleration is change in velocity per unit time, or rate of change in velocity, given by Vf minus Vi over delta t. Okay, then the question is, do we know these variables? Acceleration is what we are looking for. Okay, Vf, we are talking about section W. Vf is 10 meters per second. Vi is 10 meters per second. Delta t is between 100 and 0, so it's going to be 100 minus 0. Okay, giving us 100 seconds. So what is next to substitute? So you're going to say A is equal to Vf, which is 10 minus 10 over 100. Answer is 0 what? Meters per second squared. Yes, here I think by now we must know that a body which is moving with uniform velocity has 0 acceleration. Yeah, then comes this one. Calculating acceleration in section X. Okay. Yeah, like we said before, acceleration is equal to change in velocity over time. So when you come to check what you know, acceleration is wanted, but Vf is, you have to know that we are talking about phase X, and our Vf is 25 meters per second, and our Vi is 10 meters per second. Delta time, or change in time, is from 150 to 100. So it's going to be 150 minus 100, giving you 50 seconds. So what is next to substitute? So you're going to say acceleration is equal to VF, which is 25, minus VI, which is 10, over 50. This one will give you 15 over 50, which is equal to, giving you this 0.3 meters per second squared. Then we come to Y. Calculating acceleration of the cyclist in the section Y. We must not forget that acceleration is given by change in velocity, which is V final minus V initial, over change in time. Then when you come to check what you have here, acceleration is wanted, but final velocity is 25 meters per second. Initial velocity is 25 meters per second. Because it's flat, the velocity at 150 is the same velocity as 225. And then we come to change in time. Change in time is from 225 to 150, so it's going to be 225 minus 150. Giving you this. So next is to substitute. So you're going to say acceleration is equal to final velocity, which is 25, minus initial velocity, which is 25, divided by time, which is 75. This one will give you 0 over 75, which is equal to 0 meters per second squared. Then we come to phase Z. We are calculating acceleration in section Z. Okay, how do we deal with this one? You know that acceleration is equal to VF minus VI over delta t. Then you check with what you have. Do you know A is what you're looking for? Final velocity, you have to check. It is 0 meters per second. Initial velocity is 25 meters per second. Change in time is 275 minus 225. Next, then we substitute. You have acceleration equals to final velocity, which is 0, minus initial velocity, which is 25, divided by change in time, which is 50, giving you negative 25 over 50. This one will give you, will give you 0.5 meters per second squared. And negative acceleration, we call it deceleration. With that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.